Number 4, we're still solving by factoring. So what I want to do is I want to go through my factorization process. Are there any greatest common factors in all three of these terms? So is there anything that goes into x squared and the negative 5x and negative 36? And after I look at it, I summarize there's no common factor from any of those. Nothing goes into 5 and 36 evenly. And really, as soon as you have a 1 there, it's pretty much done. So next thing I'm going to do is I'm going to check to see if it's a difference of two perfect squares. It's not. It's a trinomial. So since it's a trinomial, it must factor into two binomials if it's going to factor. So I'm going to try the factorizations of x squared. It has to be x and x. The signs have to be different, so one's got to be plus and one's got to be minus. And 36, we have some options here, so I'm just going to write down the options. It could be 1 times 36, it could be 2 times 18, it could be 3 times 12, it could be 4 times 9, it could be 6 times 6, and those are all my options, but I want to pick the option that I can take not only to multiply together to get 36, but that I could add together and get a negative 5 if I need to. So if I make this a negative 9 and a positive 4, I'd end up adding and get a negative 5, but yet when I multiply them, I still get a negative 36. So these are the factors that I need to use. So I'm going to use a negative 9 and a positive 4, and that gives me the correct factorization. And now we're going to apply our zero factor theorem that I discussed on the previous one. So if you didn't look at question number 3, you can, but I'm going to apply the zero factor theorem, which says if I've got two numbers that are multiplied together that equal 0, I know that either the a is equal to 0 or the b is equal to 0. That's the whole purpose behind factoring, is to force two numbers to be multiplied together and their answer is 0. So now I know that x plus 4 has to equal 0, or my other factor of x minus 9 has to equal 0. That would force x to equal a negative 4. If we put a negative 4 in here, we'd have 0 times whatever, and times a negative 13 is still 0. And this one would be x equals a 9, and if we put 9 in here, it'd be 9 minus 9 is 0, and it's going to be 0 times whatever that is, 13, still 0. So we have two solutions, one's a negative 4 and one's a 9.